Here we do a problem on photoelectric effect. So the question is given by a laser beam with an intensity of 120 watt per meter square is incident on a surface of sodium. It takes a minimum energy of 2.3 electron volt to release an electron from the sodium. That is the work function of sodium. Assuming the electron to be confined to an area of radius equal to that of sodium atom. So that is 0.10 nanometer. How long will it take for the surface to absorb enough energy to release an electron? So we have to calculate the time interval for the photoelectric emission. So the intensity is given. So that is equal to 120 watt per meter square. We know that the intensity is the average power per unit area. So from its dimension itself, we can see that it is watt per meter square, power per unit area. So P average per area gives the intensity. So therefore the average power can be calculated as I into A. And the radius of the sodium atom is given. R is equal to 0.1 nanometer. 0.1 into 10 to the power minus 9 meters. So we can calculate the corresponding area. A equal to pi r square. So please calculate this. So once area is known and intensity is already given, we can calculate the average power PAV. And we know that the power is the rate at which the energy is absorbed. So if the entire electromagnetic power is delivered to the electron, so the energy is absorbed at the rate equal to the power. So we know that power P average here is energy per unit time, E divided by T, or delta E by delta T. So here the energy, the minimum energy to release the electron is given. E is equal to 2.3 electron volt. So that is the work function of the material. So the time interval delta T, or you can write this as delta E by delta T, and this is our delta E. So the time interval delta T that is needed to absorb an energy delta E, which is given by the work function. So ഇവിടുന്ന് E തന്നിട്ടുണ്ട് P average. Delta T calculate ചെയ്യാനേ ഉള്ളൂ. Delta T is equal to delta E by P average, or E divided by P average. So delta E is nothing but the work function of the material 5. So P average is nothing but the intensity multiplied by area. So using this expression, you can easily calculate the time interval needed for absorbing the electromagnetic radiation. So we have seen that soon after it absorbed the electromagnetic radiation, it emits electrons. So photoelectric emission is an instantaneous process. So whenever it's absorbed energy, it can release the photoelectrons. So the photoelectrons are emitted in the time interval of the order of this. Okay, thank you.